Hey, what's up everybody? It's Miss Brothers. I just want to walk you through, this is the stoichiometric conversions practice number 1, specifically molar mass, and this is something that we tackled on Monday the 6th, and so I want to walk you through just working on these problems and going through the process. Now, a couple of things to remember. Recall that molar mass is the number of grams of 1 mole of a substance. Okay, and again, you're going to have to use your periodic table, or you can also use a P table in order to figure those things out. Okay, so we're going to go ahead and jump on into this, and just know, you guys, that some of the stuff I'm going to be doing, I will be doing some rounding, so just know that that is, if you don't have the exact same answer that I do, it may be that I just did some rounding. The first thing you're going to want to really take a look at is this first section right here, this instructions that says if you want to cancel grams, grams should be on the bottom, and that should be your ratio with moles on top. If you want to cancel moles, moles should be on the bottom of your ratio, and your grams should be on top. And you'll see what I'm talking about as we go. So let's jump into this. And again, you guys, more than anything, process, process, process. All right, so number 1 says, what would be the mass of 0.50 moles of, this is copper nitrate. Hint, the first molar mass of copper, it says first find the molar mass of copper nitrate for your ratio. We'll do that in a minute because I really do like to get my things set up first. Again, you guys, setting up a T-chart. So what we're trying to find out is this. What would be the mass? So we know that if we're finding mass, our unit has to be grams. So when we're done, the unit we should see in our answer is grams. So let's go ahead and set this up. We're given this unit, the unit of moles, so, and that's 0.50 moles, M-O-L, because that's the abbreviation we use for moles. And specifically, this is CuNO3, 2. Okay? And I like to put a parentheses around that whole thing, because that way I know that that's part of my units, and I'm going to set that over 1. And now, according to this, if we want to cancel moles, it means we have to put moles down at the bottom. Now, technically, you guys, what we know is that a mole of CuNO3, 2, is going to end up being some unit of grams when we're done. We know that our unit when we're done is going to be grams. Sorry, I broke my lead. I'll do that more than once today. Grams of CuNO3, 2. Okay? So what we have to come up with in this little blank right here is we need to come up with what mass of copper nitrate is the same as saying 1 mole. And so we have to figure that out, and we're going to figure that out using our formula. Now, I'm going to grab a little separate sheet of paper here because it gets to be a little bit convoluted if I put it all on one sheet. So I have CuNO3, and I have 2 of those. Okay? So the first thing I have to do is I have to figure out how much of everything, what is the mass of everything I have in this formula. So I've got copper, and the atomic mass of copper is 63.55 grams. Now I only have 1 atom of that, so essentially my final mass of copper is 63.55 grams. I've got a nitrogen right here, and remember, you guys, if it's in these parentheses, it means this subscript out here is going to change the number of atoms of nitrogen I have to 2. So I've got nitrogen times 2. Now, the atomic mass of nitrogen is 14, and we're going to say 0.1 grams. That's a rounded figure, but we're going to take that. So if I multiply that, 2 times 14.01, that's going to give me 28.02 grams. And then the last thing I have in this formula, I have oxygen. Currently I have 3, but remember, I have to take that quantity times 2. 3 times 2 is 6. So I actually have 6 nitrogens times 16.00 grams, because that is the atomic mass of oxygen. And then if I multiply that out, I end up with 96.00 grams. And if I add all those up, what I end up with is 187.57 grams. That is the mass of this quantity of copper nitrate. So what I'm going to do is I'm going to take that quantity right here, this 187.5, and that's what I'm going to fill in right here. 187.57 grams of copper nitrate. Okay. Now what I have is I'm now in a position to go ahead and do my. Sorry guys, I'm going to move some stuff around here for a second. There we go. I'm now in a position to cancel my units. So that's what I'm going to do next. So I've got moles of copper nitrate here. I've got moles of it down here. And now what I'm ready to do is I'm ready to do my multiplication, again, going from left to right. I'm going to go ahead and put my units here because my units are going to be grams of CuNO3 2. And when I do my math on that, I end up with 93.76 grams of that. So my final answer needed to be in grams. It is in grams. And so we did our one-step conversion right there. Well done. Okay. Let's go. And again, you guys, a couple of things to remember. If you want full points on this, I'm looking for that T-chart. I'm looking for units throughout the problem. I'm looking for you to show me that you're canceling. I'm looking for your final answer. I'm looking for the unit, and I'm looking for the stuff that we had to find. In this case, that stuff was that CuNO3 Number 2, how many moles would be in 500 grams of sugar? Well, we need to find the number of moles. It tells us right there. I know I have 500 grams of sugar, and that's what this formula is. C6H12O6 is the chemical formula for sugar, and we're just going to use the word sugar in our problem. So I've got 500 grams of sugar. I'm going to set up my T-chart. I'm going to set that up over 1. And now I have to be able to cancel out grams, which means I have to have grams of sugar down here. I don't know how many grams of sugar that is yet because I have not calculated the mass just yet. I do know that I'm going to put 1 mole at the top right here. And again, you guys, because if you recall about molar mass is the number of grams per 1 mole of a substance. And so that's why I'm putting 1 mole at the top here. So let's figure this out. Let's figure out what our mass is of this molecule of sugar. So I'm going to go back to my piece of paper here. And I'm going to set up C6H12O6, okay? And I'm going to take some time to figure out what I have. I know I have carbon. I know I have 6 of them. And I know that the atomic mass of carbon is 12.01 grams. And again, that's rounded. I've got 12 hydrogens. So I've got hydrogen times 12 times 1.01 grams, because I know that's the atomic mass of hydrogen, and I've got 6 oxygen. Oxygen times 6 times 16.00 grams. So if I do the math on all of these, I end up with 72.06 grams of carbon. I've got 12.12 grams of hydrogen, and that's because I've simply taken, like for this carbon, I took 6 times 12.01. I get this number right here because I take 12 times 1.01, and I'm going to end up, by taking 6 times 16, I end up with 96.00 grams. And if I add all that up, I end up with 180.18 grams. So what I know is that the mass of this molecule of sugar is 180.18 grams, and so that's what I'm going to write in my formula here. So that's what has to go down here, 180.18. So now what I can do is I can go through and I can cancel out some units. So I'm going to cancel out grams of sugar here. I'm going to cancel out grams of sugar here. And I'm going to go ahead and multiply from left to right. So I've got 500 moles over 180.18. And if I do the math on that, so let's go ahead and bust out our handy calculator here. If I do the math on that, I've got 500 divided by 180.18 equals, and I'm going to go ahead and take this to the nearest hundredth, which is going to give me a final answer of 2.7, and then I'm going to let this 5 move this 7 to an 8. And again, you guys, my unit is moles of sugar. So again, that's the answer I'm going to circle. I needed to know how many moles. I have figured out how many moles of sugar there are in 1 molecule of sugar, or how many moles of sugar are in the mass of 1 molecule of sugar. So, well done. All right, let's go to number 3. Number 3, what is the mass in grams? So I know I'm looking for mass. I know my final unit has to be grams. And I'm given 4.70 moles of sodium. Okay? So I've got 4.70 moles of Na, and I'm going to just put that in parentheses over there because that's my unit. Set that over 1. I know I have to cancel out moles, so I'm going to go ahead and put 1 mole down at the bottom. Now, as far as finding the mass of sodium, that's pretty straightforward. You're simply going to go to your periodic table. You're going to look for the mass of sodium, and the mass of sodium is in the neighborhood of like 22.99. We're going to go ahead and round that up to 23.00 grams. So like I said, you don't have to go very far on this one. And again, grams specifically of sodium, moles of sodium. So now I can cancel this out and this out, and now all I have to do is do my multiplication, and that's going to be 4.70 times 23.00 grams of sodium. And when I'm done, the answer that I'll end up with is 108.1 grams of sodium. That one was super easy, don't you think? I think that one was easy. All right, you're doing great. You guys stay with me. And again, you guys, the first process as we move into number 4 is figuring out what do I have to end up with? How many grams? So I know that my final unit has to be grams. Are there in 0.35 moles of water? So this is my starting unit. I start with moles. Let's get that over here on our T-chart. 0.35 moles of H2O. And again, we're going to set that over 1 because we're setting up a ratio. And we know that if I have to get rid of moles, it means I have to put moles down in this box. And again, you guys, according to our original instructions, it says molar mass is the grams per 1 mole of a substance. And so that's why when we come down here and we're trying to cancel out moles, we're going to put 1 mole right down there. Okay? So now what I have to do is I have to calculate the mass of 1 molecule of H2O. I'm going back to my handy sheet of paper, and let's do this together. H2O. I know I have hydrogen, and according to this subscript, I have 2 hydrogen. According to the periodic table, the atomic mass of hydrogen is 1.01 grams. I've got 1 atom of oxygen, so oxygen times 1 times 16.00 grams, and I get that 16 from the periodic table. So 2 times 1.01 is 2.02 grams plus 16.00 grams, and if I do the math on that, I end up with 18.02 grams. So what we've just figured out is that 1 mole of water is the same as saying 18.02 grams of H2O. And again, I have to put my H2O over here as well. So that means I can cancel out my unit of moles of H2O here and moles of H2O down here. And again, now it's just a matter of doing my multiplication from left to right. 0.35 times 18.02. And if I do the math on that, I'm going to end up with, and we can just do that right now. We'll do it together. I like mathing together. So again, we're down here. We're going 0.35 times 18.02 is, and we're going to go ahead and round that to the nearest hundredth. We're going to say 6.31 grams, because that's what we have to end up with, grams of H2O. And that's what we're going to circle right there. Fabulous. Hopefully you're catching the hang of it now. We'll keep going because the last one's a little bit tricky, so we want to make sure that we have the skills that we need to get to that, okay? All right, number 5. What is the mass of 6 moles of H2SO4, otherwise known as sulfuric acid? So, again, we are trying to find the mass, which means, remember you guys, the unit of mass that we use in these particular problems is grams. So we know that's where we want to end up right there. We are given 6 moles, so that's what we're going to put right there. 6 moles of H2SO4, and I'm going to put that in parentheses so it's nice and tidy. I'm going to set it over 1, and I know that I've got to cancel out this unit of moles, which means I have to put 1 mole down at the bottom here. And again, the reason I'm putting 1 mole is because it tells me to. Okay? All right, so now let's take a minute. And we know that we have to find the mass. And again, this is a mole of H2SO4. We know that we have to get the grams of H2SO4. That's going to be our ending unit. So let's go back to our sheet of paper and let's calculate the mass of this entire molecule of sulfuric acid. So H2SO4. Well, let's start with H. According to this formula, we have 2 hydrogens, so that's going to be H times 2. And then we know that the atomic mass of hydrogen is 1.01 grams. We have a sulfur, but we only have 1 sulfur, and we know that the atomic mass of sulfur is 32.0. And we know that because the periodic table told us so. And it looks to me, according to this formula, that we have 4 oxygens. That's what that subscript tells us, and that's times 16.00 grams. So if we do the math on that, that's going to give us 2.02 grams of hydrogen. That's going to give us 32.06 grams of sulfur. And if we do the math on that, 16 times 4 is 64.00 grams of oxygen. So as far as how much mass is in this, let's figure it out. If we add these all together, we end up with a mass of 98.08 grams. I'm going to double check my math on that. 2.02 plus 32.06 plus 64 equals 98.08 grams. So if we are looking at our formula that we have here, that's what I need to fill in right here. 98.08 grams of, so 1 mole of H2SO4 or sulfuric acid is the same as saying that that weighs 98 or has a mass of 98.08 grams. So let's go through our processes. Let's cancel out moles here. Let's cancel out moles of H2SO4 here, and that's going to leave us our unit of grams of H2SO4. And again, if we do our multiplication from left to right, that's going to be 6. And let's go ahead and do that together. That's going to be 6 times 98.08. 98.08 equals, we'll go ahead and just do that whole number, 588.48 grams. So if we have 6 moles, that means we're going to have a mass of 588.48 grams of sulfuric acid. Ooh, and sulfuric acid's nasty stuff. All right, you guys are doing great. Let's do number 6. Number 6, we're trying to find how many moles are there in 95.5 grams of NaOH, sodium hydroxide. Okay, so we know we have to find a unit of moles. We are given the unit of grams, so we're off and running. We know that we have to take this given unit, and it goes to the very left of our T-chart, so 95.5 grams of NaOH. And again, because this is a ratio, we're going to set it up over 1. Now, because we have grams up here, it means we have to have grams of NaOH right there. And again, you guys, the reason that I take the time to write the substance in is because when we start getting a little bit more complicated, and if we start using different materials, we're going to have to be able to keep track of what's in our T-chart, okay? We know that we will have 1 mole at the top, and we have to calculate, based on this formula, the mass in grams of 1 mole of NaOH. So let's go ahead and let's go back to our piece of paper. We have NaOH. So we know that we have a sodium times 1, we have an oxygen times 1, and we have a hydrogen times 1. So the rounded atomic mass of sodium is 23.00 grams. The rounded mass of 1 atom of oxygen is 16.00 grams. And the rounded mass of 1 atom of hydrogen is 1.01 grams. And if we take the time to add those up, we end up with a quantity of 40.01 grams. Let me just double check my math right there. 23 plus 16 plus 1.01 is 40.01 grams. And that is what we are going to fill in our formula right here. 40.01 grams of NaOH. I have to put my unit of stuff right there. Now I'm ready to cancel. I've got grams of NaOH up here. I've got grams of NaOH down there. I can cancel those. And again, I'm going to do my multiplying across my table. So I've got 95.5 grams times 1, which means I've got 95.5 moles, because that's right, I canceled out that gram over there. So that's going to be moles of NaOH over 40.01. And again, I've canceled out all my units, so I don't have to worry about my units down here. So now I have to just do some final math, and let's go ahead and do that together. I've got 95.5 moles divided by 40.01, and that's going to equal, when I'm done, we're going to round that to 2.39 moles of NaOH. And that is what I'm going to circle. We're just cruising along right now, aren't we? All right. So this next one is a little bit tricky, but it's not that tricky. We freak out a little bit when we see zinc too, but I will tell you why you don't need to freak out. Here we go. So what number of moles? So I'm trying to find the number of moles, that's the unit I want to finish with, are there in 50 grams of zinc 2. And I'm specifically looking for are there in 50 grams of zinc chloride. So specifically zinc 2. This is an ionic compound, so that's why it's specifically telling you which zinc, which ion that you're going to use. But that's not really going to affect you because the atomic mass is going to be the same, because we're dealing with not so much the ion. The ion, in terms of its mass, is the same as the element, okay? So with that said, let's go ahead and set up 50 grams, because that's the unit that we are given, and that's, again, Zn. Oops, I did that wrong. I wrote it wrong. ZnCl2. And we're going to go ahead and set that over 1. Now we have to be able to get rid of this unit right here, this grams, which means that we're going to set up grams of ZnCl2 down here, and up here we're going to set up 1 mole of ZnCl2 because we're doing molar mass. So let's go back to our piece of paper. I'm going to flip it over and we'll work on this side. And we have the chemical formula ZnCl2. Okay, so we have zinc over here. We have 1 zinc. We've got chlorine right here, and we've got 2 chlorines. So in setting that up, like I said, we have a single zinc. So the atomic mass on that zinc is going to be, what is that? 65.38 grams. Now I've got 2 chlorines, which means I have to multiply that by the atomic mass of chlorine, and the atomic mass of chlorine is 35.45 grams. Let me just check my number on that real quick. 35.45 grams. So that's going to then leave me 65.38 grams plus 70.90 grams. And I got that 70.90 by simply taking 2 times 35.45. So now I'm going to add these two numbers together. And when I'm done with that, I end up with 136.28 grams. Okay, so that essentially is the entire mass of a single molecule, or in this case, a single bond of, a ionic bond of ZnCl2. Okay, so we'll go ahead and come back to our problem. Let it focus here. There we go. And we end up with 136.28 grams of zinc chloride. So we have to go through and do our canceling. So I can take that unit and I can cancel this unit up here. And again, I have to do my cross multiplication. So I'm going to end up with 50 mole excuse me, of zinc chloride over 136.28. I don't have to worry about a unit because I've already canceled it out. Sorry, guys, I'm going to take a quick drink of water here. So much talking. And when I'm done with that, I have to go ahead and do some division. I'm going to take 50. I'll get my calculator out here. 50 divided by 136.28 equals, and I'm going to go ahead and round this to 0.37 moles of zinc chloride, ZnCl2. And I'm going to go ahead and circle that. And so again, all I'm saying here is that if I have 50 grams of zinc chloride, it's the same as saying 0.37 moles of that substance. Okay? Now, as far as this challenge question, I did ask you in the instructions on Google Classroom to go ahead and do this problem as best you can. Just wanted to see what you came up with. In order to do this, we have to kind of think through this a little bit. So let's read what we have. It says, if there are 6.02 times 10 to the 23rd atoms per mole of a substance, how many atoms would there be in 2.75 moles of chlorine? All right, well, let's figure out what we have. So we have this little bit of information for us. So, and we know this. We know that a mole of anything is 6.02 times 10 to the 23rd. But notice what we're trying to find. We're trying to find how many atoms would there be in 2.75 moles, and specifically we're looking at chlorine. So before you get all wigged out by this, again, let's go back to our process. And the first part of our process is finding out what we have to find. So when we're done, we have to find atoms. That has to be the unit in our final answer. What have we been given? We've been given the unit of moles, and specifically 2.75 moles. So since that's the given unit, we're going to set up our T-chart, and we're going to set it up just like we always do. We're going to say 2.75 mole of chlorine. I'm just going to put that in parentheses over here. And like always, we're going to set it over 1. So now what we have to do is this. We have to remember that if we have 1 mole of chlorine, it's the same as saying 6.02 times 10 to the 23rd. We know that because it tells us right there. Okay? This time, you guys, we're not dealing with mass, molar mass. We're simply dealing with the number of atoms in a mole. So if we want to figure out how many atoms there are in 2.75 moles of chlorine, this is exactly what we're going to figure out. Okay? Now in this one, you guys notice that we don't really have to figure out the atomic mass of anything because we're not figuring out grams right now. We're just figuring out number of atoms, okay? Once we've done this, it's pretty straightforward. Now we just have to cancel out moles of chlorine here and moles of chlorine here. I forgot to put my little chlorine up at the top here. Can't forget that. And now I just have to do this math. And this is what we practiced last week by putting a number like this in our calculator. We're taking 2.75, and again, you guys, we're multiplying from left to right, and we're multiplying that times 6.02 times 10 to the 23rd. And in order to do that exponent, I have to use my calculator, and because I'm using the 30xa, I'm simply going to go right here to this button, the EE button, which is right over the 7. I'm going to click on that. My little exponent is going to pop up here. I'm going to type in 23, and then all I have to do is hit the equal sign, and it gives me this number. It gives me 1.655 times 10 to the 24th, and I can just round that to 1.66. 1.66 times 10 to the 24th atoms of Cl. Okay? The hard part about this one is that you think you have to, because we've spent this entire time doing molar mass where we had to calculate the masses of the chemical formula or the element that we were given. We don't have to do that here. We just have to pay attention to what we're given. We're given the fact that if I have a substance, in this case the substance is chlorine, if I have a mole of that, it's the quantity is 6.02 times 10 to the 23rd. If I have 2.75 moles of chlorine, as long as I keep my head and remember that 1 mole of chlorine is the same as saying 6.02 times 10 to the 23rd atoms, then it's just a matter of setting up your formula, your T-chart, canceling out your units, and then just doing the math and coming up with your answer, and just remembering how to use your calculator to deal with something where you're taking a quantity times an exponent. Okay? So there you go. There is your sheet. I know this is kind of a long video, and of course you're not ever required to watch the whole thing. Feel free to skip around to any part you need, but there you go. That's our first practice with stoichiometry and specifically molar mass conversions.